Good morning, everyone. Let us continue the next part in the same chapter of force and pressure. Here we will discuss about the pressure. As I said earlier, force is applied in our daily life activities everywhere. That is, force is important for all activities. Whenever we apply force on any surface, on any object, in that place, at the point of application of force, definitely the pressure will be developed. Suppose if I press the board with my hand, I apply the force on that part where the force is applied, definitely the pressure is developed. So it means pressure is completely related with the force. Pressure is completely related with the force. But it is not only related with the force, it is also related with the area on which the force is applied. On how much area the force is applied. Taking an example, I applied the force with my hand on the board. But that force can be applied in different way. If I take two different way, one is the force is applied by the palm. Now here if I say this is the portion, this is the area on which the force is applied, then the second method is I can apply the same force with my finger also. Here the force is applied for this much portion. So here if we see, I applied the force on this board and the same force is applied on this board. And you see that in both the cases, we feel different effects on our hands. On one case, we feel more pain. That is definitely, in this case, you develop some pain on your hand. Here also you feel some pain on your finger. And you can observe in which case it is more. Definitely on this part where the area is small. So that means the pressure developed is also depending on area on which it is applied. Area on which the force is applied. So pressure is depending on the force applied and the area on which the force applied. So simply we can define the pressure. They can define the pressure. Pressure is equal to, it is defined as the force applied per unit area. Simply by formula it can be given force upon area. Force applied per unit area. Symbolically it can be written as P equal to F upon A, area. This is the formula. So pressure is force applied per unit area. It means the force is applied on how much area. That is the pressure. Formula, pressure is equal to force upon area. And the pressure is also a quantity like force and area. If any quantity is measured, then definitely it will have unit, SI unit, standard unit. In the beginning of this chapter, we were talking about the SI unit of force, that is Newton. It is Newton. And You must know the unit of area in your maths classes. In the class 7th, 8th, you could have find the area of various figures, square, rectangle, triangle, whatever figure. You could have find the area. And that area was measured in terms of meter square or square meter. Meter square or it is meter square. So if we write the SI unit of pressure, this is Newton per meter square, or simply we write it is Newton per meter square. This is the unit of this pressure, but for the pressure separately a unit is given, because this pressure term it was discovered by a scientist, Blaise Pascal. It is the name of scientist. In this name, in the name of scientist, the unit of pressure is given, that SI unit of pressure is it is Pascal. It is Pascal. Symbolically it should be written as capital P, small letter A, that is Pa. That is the SI unit of pressure. So we can write that in the place of pressure we write Pascal is equal to, that is Newton per meter square. If we write 1 Newton force and 1 meter square, then the pressure is 1 Pascal. Means whenever we apply 1 Newton force on 1 meter square area, then the pressure applied is said to be 1 Pascal. So here we can define 1 Pascal also. The pressure applied on any surface is said to be 1 Pascal when 1 Newton force is applied on 1 meter square area. That is the 1 Pascal. So this is one important term that we have to remember this whenever the force is applied. Because in many of the daily life activity, this pressure term is used. Now, just we analyze this formula, that how this pressure is changing with respect to area and force. Mathematically, here we are going to analyze this formula mathematically. Suppose if I take a surface, horizontal surface. On this surface, if I put 100 gram object, this 100 gram object apply force on the surface. Apply force on this surface, on this portion, this metal portion. So definitely the pressure will be developed. Then if I put one more 100 gram, now the total is 200 gram. So on applying force by 200 gram, the force definitely increases. Force increases. If we put one more 100 gram, again you see the force increases. So keep on adding the more 100 grams, you find the pressure increases. On the surface, pressure increases. Here you see the area. We are adding the weight on this part, but the area remains same. So here area remains same, it remains same, but we are increasing the force. On increasing the force, the pressure also increases. That means we say it is pressure is directly proportional. This is the symbol to show directly proportional to the force. That means if we increase the force, the pressure also increases by keeping area constant. It is a symbol. And this is one relation. Then, if we can see the next factor also, that we can see in the discuss in the next session.